We are picking back up where we left off yesterday in lesson 7.4. We were working to use these properties of logarithms we had first started by trying to put things into one logarithm, right? That was the previous section. So, took multiple logs, condensed them into one log. Now we're going the opposite way. We're going to take one log, expand it, write it in multiple logs. So I asked you to work on C while you're waiting on me to get ready. Log base 3 of 250 over 37. Thoughts of how to start? Okay. Quotient property. Quotient property tells us if there's division inside the log, we can write it as subtraction of two logs. Good. So log base 3 of 50 minus log base 3 of 37. What?
You mean 250?
Yes, I do mean 250.
No, I keep it 50. Let's see what's plays out.
I was going to say, because I would have got a much different answer.
Okay. Nope, yep, keep it 250. Sorry, my apologies, thank you. Now, thoughts on where to go next?
I stayed here. I didn't see it anywhere.
Okay. So, and here's what I'm going to say, is first of all, you should be checking the gold paper, yes. 250, 37, are those on our gold paper? And they're not on the gold paper, so that's fine. Now, one thing, and I don't know how much of this you'd see on Math Excel, but one thing we are going to think about in this one, so I'm going to show you something you could do. 250. It's not on the gold paper.
Oh, think about that one. I feel like
What could 250 break into? 125 and 2? And why would we maybe think about 125? It's because it's what? Okay, it's 125 is a perfect cube, and it's on the gold paper, in other words, right? So,
I said that.
okay, log base 3, 250 is the same as saying 2 times 125. Agreed? Okay. We picked this because 125 is on our gold paper. So now, if there's multiplication inside of a log, what can I do? Split it into 2 logs that are being added. So I could split this into log base 3 of 2 plus log base 3 of 125. And officially, don't forget, we also had up here minus log base 3 of 37. I'm not doing anything with 37 because 37 is 37. It's prime. It doesn't have any factors other than 1 in itself. Okay. The whole point of using the 125 was what? 125, according to our gold paper, is 5 to the third. So, log base 3 of 5 to the third. And what about when we have a power? Okay. Power property says this 3 can be moved out front and written as a quotient, or as a coefficient. Wrong word, sorry, coefficient. So this could be 3 log base 3 of 5. So I still had log base 3 of 2 at the front, plus the 3 log base 3 of 5 we just got, minus log base 3 of 37 that carried down from our very first step. And now you'll notice my insides are 2, 5, and 37. They're all prime numbers. There's nothing you can do with those. None of my bases and insides are the same to where I could use identity property. So we've done all the steps we can at that point. but just something to look out for. Sometimes you can break numbers down. Sometimes they'll be helpful. So you want to look for those pieces. Questions on that one?
If we have a test that's like that, do we need to break it down that far?
In all honesty, I don't know that
If I stopped at the very first.
Yeah, I don't know that I would take it that far. Necessarily have something that would go like that on a test. I would have it a little more obvious where, numbers separate from variables and things like that. I don't know that I would have you splitting a number on a test.
Questions like that are why I don't do the homework.
Okay, let's do D. Log base 3 of 9x to the 5th. What do you notice?
There's multiplication, so you can add it.
Okay, so 9x to the 5th is 9 times x to the 5th, right? We always say 9x to the 5th, but it comes from 9 times x to the 5th. So if there's multiplication in the log, rewrite it as logs being added. So log base 3 of 9 plus log base 3 of x to the 5th. That arrow is going straight into the top of that 9. Yes?
So before we did the adding, because it's also a power property, so could you move the 5 over first?
Okay, on this one, you could not move the 5 over as the first step because the 5 is only the power on the x. It's not also the power on the 9. And so up here is where I'm understanding Reese is asking. That up here I could not start with power property because 5 is only on the x. It would have to be on the entire 9x to start with power property. Okay? So that's why I started with it's 9x to the 5th, so 9 times x to the 5th. Now, with that being said, I said we couldn't have started with the power property up when it was one log.
Now,
Could we use the power property now instead? Or now, not instead, but just now. Okay, so we can use the power property and take the 5 out front. And so this becomes plus 5 times log base 3 of x. Okay, so yes, you can take the 5 out front after they're separated. Any thoughts on log base 3 of 9?
3 squared.
Yeah. 9 is 3 squared according to our gold paper, yes. So, log base 3 of 3 squared. Log base 3 of 3 squared is 2. Remember, do you remember the identity property from yesterday? If these 3's are the same, which they are, then it's just equal to the exponent. So this is just equal to 2, and we have 2 plus 5 times log base 3 of x. I know my morning class asked about, can I move that power of 2 out front? And yes, you could move the power of 2 out front. That's 2 times log base 3 of 3, which ends up becoming 1. So 2 times 1, which is also 2. Am I done?
No. Leave the there you have to start.
No, because,
That's a 5 log.
okay, it's a 5 log base 3 of x. The 2 is a 2. They're not like terms, essentially, right? That's the short of it. So it is done at 2 plus 5 log base 3 of x. Okay, so common mistake there, and that's why I wanted to get out of the way, would be say, oh, 2 plus 5 is 7, 7 log base 3 of x. But realize the 5 is attached to the log, the 2 doesn't have an equivalent log, so we're done there. Did you figure out where you went wrong, or what extra piece you had?
Yeah, so when I moved to put a 9 and then put 9x, So I ended with a third term.
Okay. Okay, E. Log of x squared, y squared, z to the negative first.
You gotta use the product property and break it into lots of pieces.
Okay, the product property and break it in lots of pieces. How many pieces are you suggesting?
4.
3 pieces? Now, my others we've only broken into 2 to start off with. But notice this time we can see right off the bat there's an x squared, a y squared, and a z to the negative first. So yeah, let's go ahead and break it into 3. Since those inside pieces are multiplied, our 3 logs are going to be added. So log of x squared plus log of y squared plus log of z to the negative first. Okay, now what?
Now we have to move this to the
Power property says we can move the exponents. So each exponent goes out front and becomes a coefficient. So log x squared becomes 2 log x. Plus log y squared becomes 2 log y. What about log z to the negative first? Okay, go ahead and get your question here.
As a reminder, something about the negatives on 7.3. I have the same question. It says the inside parts of the logarithm can never be negative.
Okay, so the exponent is negative. Z to the negative first is negative. But the value of z is not necessarily negative. So it's fine. Okay, so the idea is, because remember, okay, so the question, in case I've got virtual listening as well, was, okay, we thought the insides of a log could never be negative. True, valid point, good to know. We don't know what z is, right? Z is some number. We have to assume not negative. But when we take z, say if it's 5, what happens when you raise 5 to a negative 1? What do we do with that negative exponent? It takes it to denominator, right? So if you have a 5 in there, it now becomes 1 over 5, which is still a positive. Okay, so a negative exponent is fine. Now if it's a negative value, we'd have a different story. Okay, good question. Okay, now that kind of leads into, note we just said that a negative exponent takes it to the denominator, right? Okay, so when I move this negative exponent out front, well, we move the negative exponent out front, it's adding a negative 1 log z. So adding a negative 1 log z, to me, is just subtracting log z. You don't have to put the 1. You could put the 1, but you don't have to put the 1. Now, and so that leads right in, my morning class was saying, but why did it end up subtraction? This was a multiplication problem, and subtraction would indicate division, right? Well, think about that. Negative exponent moves stuff to the denominator. And so if you would have looked at this original problem, another way to write this original problem could have been log of x squared, y squared over z to the first. But it's the same thing we just did. Okay, this right here is equivalent to that original problem. And if you think about it, there's the 2 log x, right? Plus there's the 2 log y, and then the z's in the denominator, so there's the minus log z. Okay, so just to kind of explain that yes, that minus is okay. And yes, I'm boxing that as final answer. Okay? No, I'm not pulling out the whiteout.
Still waiting for that day. Why do I see log base of 81?
Okay. So get what you need on the front. And then on the back, we are talking about something called the change of base formula. And the idea here is that, for example, when you look at A back here, and it wants to know what is the value of log base 81 of 27. Do you know the value of log base 81 of 27?
I don't even know where to start.
Okay, that's not something we just know. Is that something you can just enter on the calculator?
No.
No, because our calculator, the basic functions on the calculator are log base 10. Okay, so we have something called the change of base formula that can help us find these values. The change of base formula says given any logarithm, log base b of m can be changed by using log base b of m is equal to the log of m divided by the log of b, and c is the random picked base. In other words, you can rewrite this using the log of the inside divided by the log of the base, and you get to pick what base you want. Now, with that in mind, what's a good base to pick then? 10, because your calculator can do 10 if you want to go if you need to go the calculator route, right? Okay. There's sometimes other good bases to pick as well, but that's the idea. So, for example, log base 2 of 3. Notice it's rewritten as log of 3 divided by log of 2. No base is written, so that's just indicating 10. Log of 3 divided by 2. Now, you'll also see it says or ln 3 divided by ln 2. ln, we haven't talked about it. It's another button on your calculator. It's the natural log. And we'll talk about it. We'll start talking about natural logs more on Friday, I think it is. But just realize it's another button. It works the same. Okay? So, notice the comment. We've already talked about this. We usually use log or ln because they are buttons on the calculator. Okay, now, with that being said, that doesn't mean we have to have our calculator for all of these. Some of these, yes, not all of them. So let's look at these. So let's look at example 3a here. Log base 81 of 27. I can't do that in any way, shape, or form right now. Paper and pencil or calculator. So, how can I rewrite log base 81 of 27? Okay. So, he said log base 10, 27 over log base 10 of 81. Notice, I just wrote log of 27 over log of 81 because I don't need to write the 10, right? The 10 is an invisible base. Now, I'm going to not go calculate around on this one because 27 and 81.
They're both in the 3 category.
27 and 81 are both in the 3 column. So I'm going to rewrite them using the 3 column. 27 is 3 to the third, so log of 3 to the third divided by log of 81 is 3 to the fourth. Now, if we had picked, and I didn't encourage this necessarily, but we could have picked base 3 here. And if we picked base 3, notice we could use the identity property right now. The other option, though, what can we do with those powers of 3 and 4? Move them out front. If we move those powers out front, this is 3 log 3 divided by 4 log 3. Well, what do you think I'm going to say here? No. What can cancel? Log 3's. Because this is saying 3 times log 3 divided by 4 times log 3. So the factors of log 3 over log 3 can cancel. Leaving me with what? 3/4. Now, those of you that already did it on the calculator, because you didn't want to wait on me, right? Does that match the answer? Okay, so on the calculator, if you want to practice a calculator, log of 27. Now, my calculator, I have to end my parentheses, divided by log 81. And notice it's 0.75, which is 3/4. Okay, so that's one that you could use a calculator. You could not use a calculator. Just kind of depends on the situation. Questions on this one? Okay, let's try B. Log base 5 of 36. Do we know anything about log base 5 of 36? No, so change of base formula says I can rewrite this how? Log 36 divided by log 5. Does my gold paper help me here?
There seems to be 36. Right?
Okay, 36 is on the gold paper. 36 can be rewritten as 6 squared. What about 5? Is 5 on the paper?
I'm pretty sure.
No. Am I going to be able to get the same numbers if I have a 6 squared and a 5? No. Okay, so you could rewrite it as 6 squared, but it's not going to really help you any. So, yes, you must use the calculator to get a value on this one.
Yeah.
Okay? And if you'd already worked it on the calculator, you probably have a slight indication because it's a messy decimal, isn't it?
Yeah. That's why I didn't put it down, because I didn't know if it needed to be.
Okay, so do practice using your calculator so you know how your calculator works. Log 36 in my parentheses divided by log 5. I have my answer to 3 decimal places. So 2.226, but the 5 tells the 6 to go round up to a 7. So approximately 2.227. So that is another little log trick using the change of base formula. Sometimes you still need the calculator, sometimes you don't. Okay, shall we try C? Let me rephrase that. Let's try C. Log base 8 of 32. So if we don't know log base 8 of 32, what do I do? Log of 32 divided by log of 8. Do you know anything about 32 and 8? 32 and 8, both in the 2 column. So that's the key. You need to have numbers that are in the same column. Otherwise, you might as well just go straight to the calculator, right? So 8 and 32 in the 2 column. So log of 32 can be rewritten as log of 2 to the 5th. Log of 8 can be rewritten as log of 2 to the 3rd. Officially, we need to move the 5 and 3 out front. So 5 log 2 divided by 3 times log 2. What do you know? Okay. Log 2's cancel, and you're left with 5 over 3, which is equivalent to the decimal 1.6 repeating, which if you give 3 decimal places is 1.667 once you round it. So if you did this on your calculator, you saw 1.6 repeating. which is equivalent to 5/3. Now, this is something you'd have to be careful because if they required a fraction, you'd have to give the 5/3. Okay? Or it is equivalent to 1 2/3. Okay. One more in this section. Log base 4 of 18. How are we rewriting it? Log of 18 divided by log of 4, I think is what she was trying to say. And notice we're just dropping the base because we're just thinking base 10, right? 18 and 4. How's the gold paper going for you? 4 is 2 squared, but 18 isn't 2 to any power. 18, I can only go complicate and think 2 times 9, because that's 2 times 3 squared, but what's easier at this point?
Calculator.
You're going to have to use the calculator. You can't get far enough without it.
I hate when I have to make things easier.
And you guys are saying, Mrs. Sargent, just go for the stinking calculator is what you guys are really saying. Okay. Log of 18 divided by log of 4. Have you figured out the calculator? Okay. But how to use the log button on the calculator. So. Okay, 2.085 is what I'm going to approximate it to.
I like this section.
Okay, one last thing for today. That is this problem down here.
Yeah. We can skip this one.
The speed s in miles per hour of the wind near the center of a tornado is related to the distance d in miles the tornado travels by. S equals 93 log d plus 65. What is the difference in speed between a tornado that travels 16 miles and one that traveled 8 miles? Well, good news. Did you catch it?
Basement.
They gave a formula. S equals 93 times log d plus 65. So you can't complain too much about this problem when they give you a formula. Okay. Thoughts on how we're going to do this? You've got the formula, but we have to know how to use it.
We're going to use these right now.
Well, I have to use 16 and 8 in 2 different equations.
So the question is, what is the difference in speed between one that traveled 16 miles and one that traveled 8 miles? So how do we find speed? We have a formula, right? Yeah. Okay. So realize we're going to have to find the difference between the speeds. We're going to have to find the 2 speeds, which means you're going to have to use the 2 separate distances to find the 2 speeds.
Is this the one you can plug into the calculator?
Yes.
Oh, too smooth.
I say you guys just complained. You want just go for the calculator.
I will.
Here we have to go for the calculator here.
Why is it giving so much workspace then?
Ezra.
Okay, so 93. We're going to have to do 93 log of 16 plus 65. We're also going to have to do 93 log of 8 plus 65. So we're going to have to do both of those. Log of 16, folks, it's 2 to the 4th, but this is base 10. There's nothing you can do. Grab the calculator. Now, my calculator, I can enter this all at once on the calculator. Okay, I don't have to take steps. Depends on how your calculator works, but I don't have to take steps. I can say 93, it's times log of 16. On my calculator, I don't even have to hit times. My calculator just knows if I don't enter, it's going to assume times. So 93 log 16, close your parentheses, plus 65. And I have this number for the first one. 176.983 approximately. That's a speed, so it's miles per hour.
This feels like cheating.
Repeat the process with the other one. 93 times the log of 8 plus 65. You get a 148 number. S is approximately 148.987 miles per hour. Well, we're not done yet. You don't want to round down too far. It might mess up your answer. Okay. Well, the question is, what is the difference in speed? So how do we find the difference in speed? You're going to subtract them. So 176.983 minus 148.987. What do I get? 27.996, which is approximately what? 28. And that would be 28 miles per hour. I always wait till the end to round, because if you round too soon, it can affect your final answer. Okay? Your homework to finish for tomorrow is lesson 7.4 in Math Excel. You guys have 6 minutes right now. You can get into it a little bit.
And how to solve this with my friend. I got halfway through one problem.